Hello everyone. I'm Vishaka Srinivasan from MATLAB Helper, and this is the live interactive session for the webinar that was held earlier on 2D mapping with Arduino and Thingspeak. I have with me my co-moderator Roshni and the host Abhishek Agarwal. Roshni?
Yeah, hello everyone. I'm Roshni from MATLAB Helper and I'll be co-moderating this live interactive session along with Vishaka. I'm looking forward to ask my questions to Abhishek.
So hello everyone, I am Abhishek Agrawal from MATLAB Helper. So today in the morning I hosted the webinar on 2D mapping with Arduino and Thingspeak. So in the webinar we learned about how to install various hardware support packages in MATLAB and how to code our Arduino for the ultrasonic map maker and how to send the data over the Thingspeak cloud server. So if you have any queries, please do ask us in the comment section. I will try my best to solve your queries. Thank you.
Yes. So before we start this session, I'd like to bring to your notice that we are giving away free courses for the top 5 comments. So if you have any doubts, please feel free to type them in the chat box below, because that way not only are your doubts being solved, you could also be eligible for the free courses. All right. So let's begin with the session. Abhishek, initially I just want you to explain to the viewers what exactly have you done to do the 2D mapping with the Arduino using the servo and the ultrasonic. How have you done that?
Yeah, sure. So first what we have done is we have installed the various support packages required for the Arduino and the ultrasonic sensor. We have downloaded the libraries for the MATLAB. And after that, this was the part of the software part. Now coming to the hardware part. So we have used an Arduino Uno, a servo motor and an ultrasonic sensor. So what I have done is I have mounted the servo motor. I have mounted the ultrasonic sensor at the top of the servo motor on the shaft of the servo motor, and I have connected all the things with the Arduino. And what I am doing is I am scanning the environment from 0 to 180-degree, and I am getting the data for, like, if there is any obstacles present, I am getting the data from of the distance of the obstacles, and we are then plotting it. We are doing just polar plotting it, and we are getting a 180-degree field of view.
Okay.
Okay. So Abhishek, my first question is that can we change the digital pin defined in MATLAB script to any other pin, or is it not possible?
Yeah, it is very much possible to define and change the pins of Arduino to any other pins as we want. According to our convenience, we can change it, and it is very much possible we can directly change it from our MATLAB script itself.
Okay. So in case we want to use a different board, then should we make any change?
Yeah, in there is a slight change, like in the MATLAB script itself, we are mentioning which board we are using, whether it's an Arduino Uno, Nano, or Mega, or any
Okay.
other board. So we can directly in the code itself we can change that word to from Uno to Nano or Nano to Mega and some or something.
Okay.
Can you show where we'll be changing in the script?
Yeah, sure. Just a second, I am sharing my screen.
Yes.
I think the code is visible now.
Yes. Yes.
Yes.
So this is my code. So like in this line number 13. So here I am creating a Arduino object. So in variable A, I am creating an Arduino object. First, I am mentioning the port number to which I am connecting. I am mentioning the board, like I currently in this webinar, I am using Arduino Uno. So I have mentioned Arduino Uno. If suppose someone wants to use Arduino Nano or Arduino Mega, then just simply change this Uno to Nano or Mega. And these are the libraries that we are using, like HCSR04 ultrasonic library and the servo library. And now coming to the pin number. So in this line number 16, we are creating a ultrasonic object for the ultrasonic sensor, and I am using a function add-on as we are adding a libraries. and then E is the Arduino object to which Arduino we are connecting the ultrasonic sensor, and Rodrigo Tech HCSR04 is a library name, whereas and D12 and D13 are the pin number to which I am connecting it.
Okay.
So we can connect it to any other pins and we can just change the pin number to that pin. So this is the only difference that is gonna make.
Okay.
Okay. So, like Roshni asked, if we are changing the board or something, then where will we make the change for that?
I
For the
couldn't get
board.
you, please.
Instead of Arduino Uno, when we
Yeah,
are
yeah,
changing the board.
for the board, yeah, for the board, like in pin number 13, sorry, line number 13, like I am answering Uno as we are using a Arduino Uno board. So suppose I am using a Nano, we can just simply change Uno to Nano.
Okay. Okay. So we have a question from the live session. It's from Garvit, and he's asking, how can I make Arduino work with MATLAB, and what components do I need for it to work?
Like we don't want any extra components to work Arduino with MATLAB. We have to install some of the packages, hardware support packages for the Arduino, which is available in the MATLAB itself. And in the morning webinar, I showed the process of how to download hardware support packages in MATLAB. And in our website, there is a blog itself for that, and all the steps are available there. How to download the support packages and how to connect the Arduino to our PC.
Okay. Okay. So I hope, Garvit, your doubt is solved. Moving on.
So in the morning webinar session, we had a question from Trilochan Basantia, and he had asked like how to send a string from my own Android app to Thingspeak to then send the string to Node MCU and then to Arduino.
Yeah, basically we can send our string data, any type of data we can send to the ThinkSpeak cloud server, like integer, float, decimal, string, any type of data we can send. But like from sending from Android app to the ThinkSpeak cloud server by HTTP or MQTT protocols and by using the ThinkSpeak APIs, we can do that. And like retrieving the data from back to the from cloud server to the Node MCU by using the ThinkSpeak read function as we are doing for our MATLAB itself, and by using the MQTT protocols, we can do that.
Okay.
and like for and then to from node MCU to Arduino, what we can do is either we can like what we are doing in this webinar is we are fetching the data from the ThinkSpeak cloud server to the Arduino by using the ThinkSpeak read function. We can do that, or what we can do the serial communication between the node MCU and the Arduino microcontroller to transfer the data between the node MCU and the Arduino.
Okay.
So
Okay.
I think you Luchan Vasantya got the query.
Okay. Okay. So can you explain what Thingspeak is or what it does?
Yeah, sure. So basically, what ThinkSpeak is a cloud analytics platform. So what ThinkSpeak help is, so first ThinkSpeak gets the data from the sensors or the things that are connected with the cloud server. So we can get the sensor data in the cloud server itself. And after getting the data in the cloud server, what we can do is we can analyze the data. We can perform some algorithms, or we can visualize the data, and depending on our application, we can do simple operations on the data. So that's the main use of ThinkSpeak.
Okay. Okay.
So we have another comment from the live session. It's from Vishwa Sports Science Virtual Lab. So they're saying that they're new to Arduino. If you want to connect through Wi-Fi or Bluetooth, can you explain what are the software and hardware required for that?
Yeah, like suppose there are different types of Arduino available in the market. Like in some Arduino, the Wi-Fi and Bluetooth modules are also available. So by using that Arduino, we can, while connecting our PC to the Arduino in the MATLAB in morning session I showed you, we have a three option like we can connect like USB, Wi-Fi, and Bluetooth. If some Arduino supports USB, Wi-Fi, like Wi-Fi and Bluetooth, we can connect it directly with the MATLAB itself. We don't require any other software. And suppose if you want to connect any other things like Android app or something else to the Arduino, what we can do is we can get a Bluetooth module HC05 that is commercially available in the market. We can get it easily, and by using the HC05 module, we can like connect anything, any like our smartphone, or we can connect our PC to the Arduino.
Okay.
So there is another question. I do want to implement an Arduino based project and I'm of EC field. Any suggestion on the topic which I can implement easily as per college level?
Yeah, there are many projects that are available. Like in EC field, like what we have done in the webinar, you can implement this too. Like for you, what you can do is you can make a robot, simple robot, and you can mount this system for the ultrasonic map maker. And what we can do is you can build a simply autonomous robot for that, and by scanning the data you can get the distance if there is obstacles present or not, and you can code it, and we can get a autonomous robot. So this project can be a good help for you.
Okay.
Yes.
So we have a question from Nikita from the live session. She's asking how communication is taking place between Arduino and MATLAB.
Yeah, so the communication between Arduino and MATLAB is we are doing it by with the help of a USB cable, and that's the USB cable. The communication that is happening is a serial communication. So basically, serial communication is that the Arduino and the MATLAB, it sends a bit by bit data. Like in a particular in a single time, it will send a single bit at a time. So this between the MATLAB and the PC, we are doing a serial communication.
Okay. Uh, so the next question is there any limitations on the number of data to be sent over ThinkSpeak?
Yeah, there are some limitations on the data that to be sent on the ThinkSpeak. Like we can't send more than 3 million of messages to the ThinkSpeak cloud server per year. So that's the first limitation. Second limitation is that we can't send more than 8,000 points at a single time to the ThinkSpeak cloud server. So this is the second limitation.
Okay.
And the third limitation and the last one is that we can send data to the ThinkSpeak cloud server once in every 15 seconds. So these are the three limitations that are present.
Okay.
Abhishek, can a servo motor run continuously?
Yeah, like servo motor can't rotate like just free like a DC motor, and servo motor runs on angular basis, like for 0 to 180 degree or 0 to 360 degree. Like it runs from 0 to 1 to 2 like in an angular position. So we can't run it like, just like freely like a DC motor.
Will there be any change in the connections while connecting with RPi or while implementing this using RPi?
Yeah, there will be a slight changes while connecting the same schematic to the Raspberry Pi. So, like there will be like for the servo motor, there will be no changes. Like we are using three pins: VCC, ground, and the signal pin. So for VCC ground, we can directly connect it with the 5 volt of the Raspberry Pi and the ground, and signal pin to any pins of the Raspberry Pi. And for the ultrasonic sensor, like in ultrasonic sensor, there are 4 pins: VCC, ground, echo, trigger. VCC and ground are for power supply. We can directly connect with the 5 volt power supply pins of the Raspberry Pi. And for the trigger and echo, the trigger is the output pin from the Raspberry Pi and input to the ultrasonic sensor. So we don't need anything in between that. But for the echo pin, which is the input pin to the Raspberry Pi and output from the ultrasonic sensor. So as we know, the Raspberry Pi cannot sense more than 3.3 volt. The pins or the processor may get damaged if we supply more than 3.3 volt of voltages. So what we will do is we will connect a simple 1 kilo ohm resistor in between, so that the
Hmm.
voltage from 5 volt gets dropped to 3.3 volt.
Hmm.
So these are
Okay.
the slight changes while connecting the same schematic.
In terms of the code and other add-ons and all that we have to install.
Yeah, in terms of code and add-ons, like we have to like Raspberry Pi is a microprocessor, just like it's like a mini computer. So we need an operating system to operate it. Like just in the computer, we are installing various operating system like Windows or Linux, like that. So Raspberry Pi has also its own operating system, that is Raspbian. So first we have to install Raspbian in the Raspberry Pi, and we have to install many different hardware packages for the Raspberry Pi. And like the logic part of the code will be the same, but
Okay.
there will be there may be a slight changes in the beginner part, like creating the object and all.
Okay. Okay.
Abhishek, a servo motor can't take a full rotation. So then why can't we use a stepper motor? Is there any disadvantage for that?
Yeah, like for servo motor, like stepper motor, we can do it by with the help of a stepper motor too, but stepper motor will require a motor driver. And so there will be a slight changes in the connection, and it may become a quite hectic task, like for creating like interfacing motor driver and all. Like for servo motor, we can connect the servo motor directly to the Arduino, but we can't connect the stepper motor directly with the Arduino. We will be requiring a motor driver for that. So it may have become a quite hectic task. So for this application, servo motor is the best option we can go for.
Okay. So here, what are the advantages of using ultrasonic sensor, and why have you used that instead of laser technology such as LIDAR for the 2D mapping?
Yeah, like the first is that ultrasonic sensor are very easy for the interfacing, and they are very cheap and efficient. Like they cost in like 200 rupees, but the lidar sensors, they are like very costly, and the interfacing and the coding is like very tough in comparison to the ultrasonic sensor, and their cost may go up to like 20,000 something. So that's why we are using a ultrasonic sensor for this application. But with using a ultrasonic sensor, like the sound waves may diffract with as the distance increases. So there will be a slight less accuracy. So if we want to increase the accuracy part, we can go for the lidars.
Okay.
So we have a question from Mayuri from the live session. So she's asking, can I create a hardware interface on MATLAB similar to Arduino?
Yeah, we can connect a hardware interface in MATLAB. Like we can't create in MATLAB, like we can do the modeling part in the Simulink. So Simulink provides various blocks and all. So what we can do is we can put the whole code in terms of the blocks, and by using the blocks in the Simulink, what we can do, we can directly upload that model in the Arduino itself. So that can be done. So it can be the hardware interfacing can be done with Simulink.
Okay.
Okay. So in your case, you've taken 180-degree field of view, right? Can we make that 360-degree in your mapping?
Yes, we can make a 360 degree of map. So what we can do is either we can go for a 360-degree servo motor. They are also available in the market, like some MG996 servo motors. They have a 360-degree rotation. Or what we can do is we can use two ultrasonic sensor mounted back to back. One ultrasonic sensor will give the values from 0 to 180, and the other ultrasonic sensor will give from 360 to 180-degree.
Okay.
So by using this setup, we can create a 360-degree field of view map.
Okay.
So how can we make a 3D map using the same approach?
Yeah, so for 3D mapping, what we can do is like we can have a two servo motors, one for the azimuth movement and other for the elevation movement. So by using the two servo motors, we can get a 360 degree means we can get a 3D map of the surrounding.
Okay.
Okay. So what is the range of distance that the object can be detected using the ultrasonic sensor?
Yeah, the range that the ultrasonic sensor varies from like 4 centimeter to 4 meter.
Okay.
So what is an advantage of using an ultrasonic sensor instead of an optical sensor?
Yeah, basically the advantages of using an ultrasonic sensor is that ultrasonic sensor offer great advantage while sensing clear objects, liquid level or highly reflective surface or metallic surface. And ultrasonic sensor also functions well in wet environments where the optical beams of light, by using the optical sensors, the optical beams may refract off due to the water droplets. But however, the ultrasonic sensor will perform very well in wet environments. But they may be susceptible to the temperature fluctuations or the wind. So and yeah, the ultrasonic sensor basically they diffracts, the sound waves diffracts, so there will be a slightly less accuracy in comparison with the optical sensors.
Okay.
Okay. So there is a question from the live session. It's from Vishwa Sports Science Virtual Lab again. And he's saying, thank you, Abhishek. If I want to identify the walking gait pattern, for example, heel strike, can you explain how to approach that?
Yeah, can you please repeat the question once?
So he's asking if we have to identify the walking gait pattern, for example, heel strike. Can you explain how to approach that? I think we'll if we he's asking for the sensor with which you can identify where the when the heel touches the ground or the gait pattern of the person walking.
Okay, like for something like that, like if someone is approaching a hill or and a person is walking, so he is able to detect any obstacles, like that something.
No. So he wants to understand if suppose say you're walking, what are you placing first and where are you placing the next step? Something like that.
Yeah, like we can go for ultrasonic sensor too. We can go like it. It basically the use of the ultrasonic sensor is that it basically detects the distance. It basically gives the distance of the obstacle. So like when we are placing our foot, so while placing we can get the distance of the ground, and
Hmm.
by getting the data like we can do the approach.
And also we can use like multiple arrays of ultrasonic sensor to get like a range. Suppose say a person walks
Yeah,
through
yeah,
a
yeah.
school, then we can use an array to solve that.
Yes, we can use a multiple sensors for
Huh.
that.
Yes.
Okay.
I hope your doubt is clarified. If you still have any doubt, please feel free to ask in the comment box. Vishwa.
So
Okay.
Abhishek, what is this ESP8266 and
Yeah,
how can it work?
basically, yeah. So basically, ESP8266 is a node MCU that what we got in our previous query. So node MCU and ESP8266 are similar thing. Basically, ESP8266 is also a microcontroller which is having a Wi-Fi capability, so
Okay.
that we can connect it with the internet, but the processing power of the node MCU module is less compared to the Arduino. So by using the ESP8266 module also we can do that. Like in this webinar, what we are doing is we are doing the communication by using a wired communication between Arduino and PC. If we have used a ESP8266 module, we don't have to use the wired communication, and we can send the data over the internet only. So
Okay.
this may be a advantageous.
Okay.
Okay. So there is a this question: how to set a string from my own Arduino app to Thingspeak, to then string to Node MCU and then to the Arduino. We've already taken up this query, uh, trilogian. So if you just like rewind back or something in this live session, you'll be able to get the answer. So moving on. Um okay. So do servos need PWM?
Yeah, servo motor needs a PWM signal. So basically by varying the width of the PWM signal, we can change the rotation of this angular position of the servo motor. Like for some width of the PWM, it will be from like 0 to 1, and for other width of the pulses, it may vary. So by varying the width of the pulses, we can change the angular position of the servo motor. So that's why servo motor needs a PWM signal.
Okay. So then, what's the difference between a digital pin, PWM pin, and an analog pin?
Okay, sure. So I will share my screen, and on the Arduino itself, I can show that. So just a second. So basically, this is an Arduino Uno that we are using. So on so these are the these are the digital pins of the Arduino, and these are the analog pins of the Arduino. A0 to A5, and from 0 to 13 these are the digital pins, and we can identify the digital pins from the PWM pins. Like the PWM pins are 3, 5, 6, 9, 10, 11. So you can see a wave-like symbol in front of this pin. So the wave-like symbol differentiates a digital pin and a PWM pin.
Okay.
So now coming to the difference part. So the difference between the analog pin and the digital pin is that analog pins can read analog signal, but digital pin cannot read analog signals.
Okay.
So this is the difference between the PWM pin and digital pin and analog pin. Now coming to the difference between the PWM pins and the analog pins. So when we want to write an analog signal, we can't write it directly. So we will be using a PWM pins to write an analog signal to the Arduino.
Okay.
So this is the basic difference between the analog, digital, and the PWM pins.
Okay. Okay.
Okay. Abhishek, we have a question from the live session from Garvit. So he's asking, what exactly is Thingspeak? Can we make our own website and do this data transfer to our website?
Yeah, basically Thingspeak is a cloud analytics platform. So what Thingspeak does is Thingspeak is a cloud server. We can get the data from sensor data from the sensor to the Thingspeak connected to the cloud server. And what we can do is we can analyze the data, we can plot it, we can perform different operations, we can visualize the data in the Thingspeak cloud itself. So like coming to the website part, yeah, we can make our own website, and by using the Thingspeak APIs, we can extract the data from HTTP and MQTT protocol, and we can get the data to the cloud server. And if we want to read the data to any website, we can do that. Like in the webinar itself, I explained you like Thingspeak creates a URL for our data. Like we can visualize the data in any other URL also. So by creating a public URL or something by using the APIs, we can do that. We can visualize the data from Thingspeak to the cloud server, to the website, any websites if we are building it.
Okay.
Okay. So the next question we have is the Arduino itself has an IDE, right? So then why should we prefer MATLAB?
So basically, why we are preferring using MATLAB is that first we can visualize the data very easily in MATLAB that we can't do in Arduino IDE. Second reason is that suppose someone wants to perform certain machine learning algorithms or certain wants to train the data, we can get the data easily and we can perform that in the MATLAB itself. So basically, these are some of the applications. So why we are preferring MATLAB over Arduino IDE.
Okay.
So Abhishek, in Thingspeak, so how many free channels can we create per account?
Yeah, in coming to the free channels, like in Thingspeak, we can create only four channels per account. So for the non-commercial users, we can only create four channels,
Okay.
and so this is one limitation. But if someone is going for a premium account, they can create any number of channels.
Okay.
Okay. So the thing, how do I use a table in MATLAB GUI that continuously takes various data, sensor data from Arduino?
Yeah, what we like, we can create a table in the MATLAB itself. So we can do it in the MATLAB GUI itself, like it's a part of MATLAB only. So what we can do is, first we can create a variable for getting the data from the Arduino to the MATLAB. And after getting the data, what we can do is, we can, by using table function, there is a table function in MATLAB. So
Hmm.
by using the table functions, we can create a table, and we can upload the data in the table itself, and we can visualize it in a MATLAB GUI.
Okay.
So Abhishek, we have the continuation of the previous question from Garvit, and he's asking if this is connected via cloud, can we send our data from Arduino to Thingspeak and then to WhatsApp?
Like yeah, we can connect our Arduino to the cloud server, like we are doing it here only. What we are doing is, we are connecting our Arduino to the cloud server. So by using the ThingSpeak APIs, we are sending the data. By using the HTTP and MQTT protocols, we are sending the data to the cloud server ThingSpeak. So like if someone wants to send the data back from the ThingSpeak to the WhatsApp, exactly, I don't know the procedure for that. Like I don't have expertise in the Android programming. But yeah, ThingSpeak provides two options. Like we can send the data to the Twitter, like like suppose I want to get an alert, like I am sending my room temperature data to the ThingSpeak cloud server regularly. If my room temperature exceeds more than suppose 50-degree, then I can get an alert notification via Twitter or Twitter, and one more app there is. So by using these two apps, we can get the notification by using the ThingSpeak only. So I think it can be done. There may be some way to send the data to the WhatsApp, like send the notification in the WhatsApp also,
Okay.
Okay.
by connecting the different applications like APIs and all.
Mm.
Okay. So I hope Garvit, your question has been answered. I'd also wait for like a couple of more minutes because while there are other questions coming, I'd like to guide you through the certification process. Uh, I'll share my screen. So this is the webinar quiz, and if you answer this quiz, you have to score about 60%, and then you're eligible for the MATLAB Helper certification. Now you can attempt this quiz as many times as you want. Now the other thing is, earlier I mentioned about the 5 best comments. We'll be taking up the names at the end of the session. Now an important thing is, all those people whose name will be taking, they will have to attempt this webinar quiz within 24 hours for us to help you with for us to connect with you and give you the prize. And one important thing here is, please mention your actual name when we announce your name, because a lot of times your WhatsApp ID, your YouTube ID is not same as your name. So then it becomes difficult for us to connect with you. And the premium courses that we'll be giving, just a minute. These are some of the premium courses that we'll be giving up, which is neural network, numerical methods, digital signal processing, stock market application. This is amongst the few other things that we'll be giving away. Uh, and now to attempt this quiz, this start quiz button here, you have to click on this. for you to attempt the quiz. Like I mentioned, you must get 60% or above to get the certification. These are all MCQ questions, and you can attempt them as many times as you want. I'm just randomly attempting the questions here. The bar here shows. So yeah, please keep the comments, questions coming. Moving on. Um, uh, can the there is this question from the YouTube live, and Nikita is asking, can the process be performed with a particular type of Arduino only, or is it open to all types of boards? Nikita, I think we've answered this, but Abhishek, brief them again.
Yeah, sure. No issues. Like we can perform this application with any types of Arduino, or even it is not limited to Arduino also. We can do it with any type of controllers such as STM32 or PIC microcontrollers or certain AVR or Texas Instruments microcontroller. So that support packages are also available in the MATLAB. So by using any other microcontroller or any type of Arduino board, we can perform this application and we can interface like any type of sensors. Like here, we are interfacing servo motor and the ultrasonic sensor. So there is no issues with the kind of board that we are using. Only like certain things we have to change in our script. By doing the changes, we can do that.
Okay. Okay. So, um, I think Garvit Khandelwal has commented that I think that app is Twilio. I think it is one of those apps with which you are sending.
Yeah. Yeah, sure. That thanks for reminding me. Like that was the
Hmm.
app was Twilio, Twitter and Twilio. Thanks.
Okay, okay. Um, are there other comments from the YouTube session?
Yeah, I think we have one more question. So, can we clear ThinkSpeak channel from MATLAB? How can we do that? This question is from Trilochan. Abhishek, you're mute.
Yeah, sorry. So yeah, yes, we can definitely clear the ThinkSpeak channel from the MATLAB itself, and we are doing this in our webinar also.
Okay.
Yeah, so by using the user API key, we are first deleting the channel data that is present. Suppose I want to do repeat the application many more times. So what I am doing is first I am clearing the data that are already available in the ThinkSpeak. So and then I am sending the data. So in the MATLAB script itself, we are doing that.
Okay.
Okay. Um,
So in the webinar part, I have explained how to do that.
okay. Um, Trilochen, I think your doubt should be clear. If you have, if it is still not clear, please comment on the chat box. So while we wait for the other comments, I'd like to give light on the next week's webinar, which is on control design toolbox. And in this toolbox, you learn to plot Bode plot and step response, compare the results with the predefined functions, and design the control system using the control system designer toolbox. So please ensure that you're signing up for next week's webinar as well. Looking it. So if there aren't any other questions, shall we decide on the top five comments?
Yeah, sure.
Okay.
So
Wait, I
now
think
coming to the best.
no, I think there might be other comments coming up.
Yeah, sure.
Uh, okay. So meanwhile, I'll also show about the last week's webinar details. I'll just share my screen. Just a minute, sorry. So last week's webinar, can you see my screen?
Yes.
Yes, it was on Simulink design optimization, and this you can watch the webinar here, and the live interactive session of that webinar. And for textual explanation, you can as well read the blog. The blog is also available for this week's webinar, which is also a part of the Arduino webinar series. So today's webinar is a part of the Arduino webinar series as well. So there are other webinars regarding that. So the last week's webinar was on optimization system using Simulink design optimization. And so these are the thing you will learn to pre-process the data and compare it with the real and simulated data, and sort of make a prediction on certain unknown parameters. I think we have other questions. Okay, so we'll announce the names. Abhishek.
Yeah, sure. So the five best comments are: first one is from Trilochan Basantia, and the second one is from Garvit Khandelwal. Third one is from Nikita. Fourth one is from Viswa Sports Science Virtual Lab, and the fifth one is from Mayuri.
Okay. So all those whose name we've called out, please also mention your actual name in your chat box, so that we are clear. It'll be clear for us, and you have to attempt the webinar quiz within the next 24 hours to avail the prize. So please ensure that you sign in for the next week's webinar as well. Until then, thank you. Bye bye.
Thank you.